All right, let's continue with part C. That's 4 over 3 minus e to the x. You can go back to the basic integration rules and see if there's anything similar to what we have already here. And using a u substitution for the bottom of the function is not going to help because if you call u to be 3 minus e to the x, du is going to have e to the x in it, but we don't have that in the top, in the numerator, so we can't really replace or we can't make the e to the x disappear in du expression. So what we can do here is that applying another algebra trick, which could be also listed here, but all I'm going to do is just simplifying the bottom essentially and pulling out e to the x from the bottom. Okay, so let's just do that. This is a little algebra trick so that I may have an exponential function popping at the top as well, at the end. Okay, so 4 over, I'm going to pull out e to the x in the bottom, so this becomes 3 times e to the minus x minus 1. Just simple algebra here. Okay, and then e to the x in the bottom can be sent to the numerator by taking by changing the exponent to negative x. So what I mean by that is I can rewrite this as like 4 e to the minus x. So e to the minus x. And then the bottom is still 3 e to the minus x plus 1. So this way I have the exponential minus x, e to the minus x, popping in both top and the bottom of the integral, right? So this allows me to use a u substitution, which is me calling the bottom to be u, and I'm safe now because I have e to the minus x dx at the top. So because I'm going to take when I look at the differential here, du equals minus 3 e to the minus x dx, okay? So that implies that e to the x dx is found by dividing both sides by negative 1/3, right? All right, so all I'm going to do here is to replace e to the x minus dx by negative 1/3 du. So this was a side work here. Okay, let me just continue quickly from here. So I have 4 and I have negative 1/3 du. So negative 4/3 du over u is what I have for the integral in terms of u. And that's one of the known integrals and the basic integration rules that looks to be number 5. Okay, so number 5 here is what I'm going to use. Du over u is ln absolute value of u plus c. Okay, so we're almost done, right? So I'm going to go back here and integrate this as negative 4/3 ln absolute value of u plus c. Okay, and u is originally u is 3 e to the minus x plus 1. Okay, and that's exactly what the integral is all about. So that's the final output. Okay, let's move on to part D in this video. All right, so we can consider checking the basic integration formulas here. So nothing seems to be directly applicable to what we have, and in fact, you can pause the video anytime and you can think about it. Okay, and we can go back here and check if there's any procedures that we can fit our integrand to get basic integration. One of the basic integration rules, or maybe a multiple of them, depending on our case. We have expanding the numerator, separating the numerator. I think separating the numerator could be helpful. We can also use some trigonometric ideas, or maybe multiplying and dividing by the conjugate. These are all like options to consider. But I think separating the numerator would work well. In fact, you have 1 plus cosine x over sine x. So I can split this fraction into two fractions. Okay, one is 1 over sine x, the other one is cosine x over sine x. That is cosecant x plus cotangent x. That's good news because cosecant and cotan has, so these guys have their separate formulas here. Cosecant is number 13 and cotan is number 11. So all I'm going to do is to utilize these two formulas for u equals x because I have cosecant x and cotan x. I'm just going to copy those down back here. So therefore, this integral is equal to minus ln, the absolute value of cosecant x plus cotan x. That takes care of the first integral, cosecant x cotangent x. Again, that's what I did here is splitting the integral into two parts, right? So let me just put one more step here just to be, for the sake of being clear. So cosecant x dx plus cotangent x dx and minus ln cosecant x and cosecant x plus cotan x takes care of the first integral. And the second integral is just plus ln sine x plus c, and all are coming out of, these two are coming out of 11 and 13. Okay? I think that takes care of part D. And for part E and F, please move on to the next video. All right, see you.